Let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift Admin, episode 103. You may notice that my co-host, Andrew Sullivan, is missing, and that he is at home taking care of family business, and he will be back soon. So, Andrew, we miss you. Happy belated Father's Day. To all the dads out in the world, happy belated Father's Day. I hope you got a nice day to go golf, barbecue, get away from the kids, celebrate it naturally. So today we're going to talk about multi-architecture support in OpenShift, and it's something that's been coming up quite a bit. Like we always hear about deploying on x86 and deploying on ARM and deploying on IBM and stuff like that. So like now we've got the nerds that are actually going to be able to talk to us about it and actually give us the details on it. So it's going to be a lot of fun. So Duncan, do you want to go ahead and introduce yourself?
I will, yes. Episode 103. I'm disappointed you didn't have us on for your centenary because we're so special, right?
We tried. You guys are too busy for us.
Excellent. My name's, as Johnny says, my name's Duncan Hardy. I'm a product manager in the OpenShift business unit, and one of my extreme pleasures is working with the systems enablement team, two of whom you're going to meet today. So,
awesome, Jeff. Do you want to go?
Yeah, hey, I'm Jeff Young, part of the OpenShift Multi-Arch team lead for the ARM movement, but most recently getting into leading the multi-arch compute side of things. So thanks for having us. Appreciate it.
Yeah, awesome. Thank you. All right, Andy, you're up.
Hey, I'm the manager for the ARM enablement effort, as well as the multi-arch compute work. And I used to be the team lead for the multi-arch team in general, so doing the IBM bits, P&Z, power and mainframe. So yeah, lots of good stuff. Thanks for having us on.
Nice. Well, thank you very much for coming. So like, before we get started, just everybody remember that this Ask an OpenShift Admin is part of the Red Hat office hours. So just like in office hours at a college or any other thing, it's a place that you come and ask questions, and we'll answer them. So hopefully you have questions about multi-arch support, but if you have just questions in general about OpenShift or other things, go ahead and feel free to ask, and we'll try and answer them as best we can. So before we get started though, let's go ahead and talk about our top of mind topics. And let me see if I can find these little buttons over here. Yes. All right, so there's been a lot that's been going on since we've been on. So I think the last episode we had was with Kasten, and we were talking about backups in VMware. And then we had Summit, and then there's just been a bunch of craziness going on in between, the beginning of May and now. So I'm not going to go over everything. We'll actually have an episode where we kind of catch up on what to do in OpenShift 4.13. We'll do a Red Hat Summit recap. We'll do a recap on OpenShift Commons, and we'll focus on all the new things that are coming out, and some of the other exciting things that are happening around Red Hat and the open source community. So the first thing is it was announced at Summit, and it's not really new, but it's new for us. I think it's called the Red Hat Service Interconnect, and it's based on Scupper. And so at its most basic level, it's app-to-app network configuration that a user can provision. So it's at a layer 7, and it's something I'm really excited about. Like my team is looking forward to doing a validated pattern based on Scupper, hopefully in Q4, so towards the end of this year. So it's something that like really excited about, and I can't wait to use it. Red Hat Data Hub is the Red Hat downstream, and the Red Hat upstream product for the Janus IDP, which is a midstream deployment of Backstage, which Backstage is an internal developer platform that Spotify open sourced a couple years ago. And if you're not familiar with Backstage, take a peek. It's pretty cool. It's a developer platform is a single pane of glass where your developers can come in and use golden path templates. They can deploy microservices and deploy things based off of processes and images and templates that your company or organization has already approved. So instead of having to deploy something and then get approval, it really helps enable the developer to do their thing faster. And again, I'll paste the link for Janus, idp.io. And that is, again, our, that's the midstream product, right? So that's what Red Hat is. That's a Red Hat open source community project based on Backstage. And then a big one is ACM 2.8 release. Now, what's cool about this, and this is something I'm also excited about, is that GitOps is actually built in. GitOps has always been part of ACM, but it's actually like a first-class citizen within the ACM platform. And so now it's the integration makes like application set deployment and then that overall governance of your application deployments and multi-cluster management that much easier. So looking forward to kicking the tires on that and hopefully getting some more people from the ACM team to come on the stream and talk about that. All right, and then finally, this is a little bit old because, again, it's been since May. The GitLab operator is OpenShift certified. So that's a big deal, right? They've been working on that for a long time. I can remember 2.5 years ago when the GitLab operator was first released, and we were working with the GitLab team to get that going, and we were testing it on like different versions. So yeah, I'm glad to see that it's finally out there. GitLab's a great product and a great platform. So if you're interested in GitLab, the GitLab operator should be out in the library, the operator library. So that's it for me. I'm sorry, I'm lying. That's it for me on the top of mind topics. But next week we have Gerald Nunn and team coming on to talk about OpenShift and DevOps, or DevOps and OpenShift. So really excited to have those guys coming on. And then we're working with a couple of partners to come on in July, as well as trying to get some of the teams internally to come talk about things like Service Mesh and Scupper and some other things. So the next couple months are going to be action packed, and really looking forward to it. And I'll be glad when Andrew comes back to help calm me down and do all the talking. So, but yeah, with that, I will kick it over to the team here so they can talk about multi-arch support.
Excellent, thanks, Johnny. I was you talking about Summit. I was actually lucky enough to go to my first Summit this year, and it was really great to. I don't know about anyone else who managed to is starting to go back to conferences, but it was really good to get some face-to-face time with customers and partners and everything like that. And you're talking about the keynotes, and this is a nice segue into what we're about to talk about today. Actually, one of our customers that kind of kicked off one of the projects we're going to talk about today was in the keynote and gave us a call out. So I was about the only one in the audience with my arms in the air cheering very loudly, but it was really good to see a product get mentioned. So yeah, I think we're here, if you want to, we're going to start with a few slides and give you an impression of where we are and what we did and why we did it. And then Jeff has pulled the short straw. He's going to get to go do a nice live demo for us all. So fingers crossed. I've been sacrificing some deities in the background just to make sure everything all works. So I've probably skipped that now. And then we'll take your questions. I'm a product manager. We're always interested in questions and use cases and things like that. So keep them coming. We'll try and handle them as and when we see them and go from there. So, let's get into the part where hopefully my dulcet tones will not send you all to sleep. And let's talk about, what we're doing, the journey that we've been on, and where we go. So we're here to talk about multiple architectures, right? And I am now in this strange position, and I always have been with all many of the products that I've looked after, of having to explain what I mean by multiple architectures, because there's actually two threads to it now. So OpenShift itself, if you look at it, we've supported multiple architectures for a long time now. Andy has the scars of bringing OpenShift onto IBM Power and IBM Z. And so, since the 4.6 release, actually slightly before that, we've had support for OpenShift on IBM Power and IBM Z environments. So you can talk about that area of things in that we have multiple architectures support today. Both Jeff and Andy worked on bringing our ARM developer preview, which was based on the 4.9 release into being. So we've got now, if you look at it, x86, ARM, Power, and Z that OpenShift will all run on. But up until recently, you were only able to do that on a single cluster. So your cluster had to be, homogeneous is one of the terms you might see thrown around, but it had to be all around one type. And why did we go down that route? Well, there were several reasons. One is we were seeing growing adoption of OpenShift anyways, and in recent years we've seen that pick up on Power and IBM Z environments. So they're on the mainframe side, they've gone through the journey that many of us on the x86 side have already been through, right? Cloud native and CI/CD and bringing all those environments together. So we're seeing kind of that picking up on that side. The other reason that we supported multiple architectures and what we're here about to talk about today is the rise of ARM, right? I've got a kind of another slide on that, so we'll talk about that. And then the customers, your need for flexibility was becoming more and more clear to us, so we needed to address that. So that's kind of one side of the house, and that's we're not going to talk too much more about that because that story's evolving now. But what about the other side of the house? And this is the idea of a single cluster with mixed architectures inside it. And this is the story that we're here to tell you about today, where we're at, what we're going to do, where we've been. And the reason that we looked at this was, again, customers driving us to it, but there were some key questions that we needed to ask. So we needed to understand what the main use cases were, what were the benefits to you, the customer, were there actually different ways to solve the problems that you were asking, for these multi-architecture clusters, and was this generally the way the industry was going? I do want to do a kind of highlight for the team because we never kind of we don't often come out and blow our own trumpet, as the expression we use over here. But this is the slide from our 4.13 release. So the team has been really busy on the ARM side. Support for ARM and Azure was pretty important for us. For those of you that have got Power and Z systems in your environment, lots of work going on there all the time. I think the big thing for us in the 4.13 release was our support of FIPS mode. So you could turn on that FIPS mode. Just one big word of warning there. It doesn't mean that your FIPS validated if you turn on FIPS mode. It just means that you're running in a mode where we're using the binaries that have been built. You'll need to look at the certifications upstream to kind of see whether the actual release you're on is fully FIPS certified. And then the bit in the middle that we're here to talk about today, so I'm going to totally ignore that column and just move on rapidly. So ARM. I would normally at this point, if I had an audience, ask people to put their hands up to say who has heard of ARM before. Who's actually, now it's more about who's got an ARM system in their room. And at Summit, I asked that very question, and I would say 90% of people put their hands up, and that's either Apple Mac users or people that have gone out. There's more and more things out there, or the Raspberry Pis that are all over the place, and that. Around the 4.9 times frame, we were kind of looking at why consider using ARM and why we would do it, and why is the industry looking at ARM. So the big thing, there's multiple reasons, but the big thing I'm seeing is just this incredible performance per watt. That's why it's in all the your handheld devices that you're seeing. That's why it's extremely interesting to telcos and the edge, but also likewise we're seeing more and more companies actually push to eco standards and being able to reduce down their cost and their CO2 footprint by using systems like this in the right places is very, very strong argument to look at it. The other reason why we looked at it was just on the cloud adoption side. So there's a kind of interesting duality here coming on. First is just pure on which clouds have ARM, right? And as we chat, all the major clouds, AWS, Azure, GCP, and several others actually all have ARM, and we saw them coming online. And again, there's a kind of dual strategy here. So you have the Apples of this world and the AWSs of this world that are designing their own ARM chips and making them work really, really well. Or you have the Azures and the GCPs of this world where they're working with companies like Ampere to bring their systems in and use them in their environment. Essentially, that's a long-winded way of saying that every cloud has it, and now customers have the choice to do it. There's another add-on there that there's suddenly an interesting price performance piece here. So when AWS first came out with their Graviton offering, when you were looking like for instances, there was roughly a 40% saving on what you would get compared to an x86 instance of an equivalent one. The differences have shrunk recently. We did a presentation with Microsoft, someone from the Azure team, and they talked about a 10 to 20% performance saving. So, price saving. Now, if you look at a lot of companies who are suddenly finding how large their cloud bills are, if you can say to them, I'm going to save you even 2% off your yearly bill or your price and cost, that's a very, very interesting thing. Why else were we considering ARM? Well, I've already talked about edge adoption. It's everywhere, right? And it's going to continue to be everywhere. What was interesting was there was a big gap in actual physical server support. And now we're seeing with the likes, as I've mentioned, a company called Ampere that are coming out with some really great servers built on the Neoverse piece. But also HP's got a device going, a server coming out. Well, it's already out actually. That's available. So those pieces are there. And then, it's great having the hardware, but you need something to grow on it. Run on it. And we're talking about OpenShift and are running on ARM, so we're there, but there's also this rapidly growing ecosystem there. So all really strong reasons to look at ARM, but why OpenShift with ARM? Well, it's all about choice, right? The thing that you should be saying time after time with OpenShift is that you will get that same OpenShift feeling experience on any platform now that you want, on any cloud that you want, and we wanted ARM to be part of that ecosystem. So what do we do today? What do we support? I haven't let Jeff and Andy have 5 minutes without asking for extra features, so we're in good shape now. We've got a full stack automation on our pre-existing infrastructure, support for AWS, Azure, and bare metal. And watch for Google coming pretty soon now as well. We want to do that as soon as possible. So we're on all the main platforms that we need to be if you want to run it. And this is really just, benefiting from that perfect storm that I talked about on the slide before. I don't know how many of you are as old as I am, probably not a lot. But it's definitely, when was it? 1985, I think the first ARM chip came out. And you can probably trace back to there that next year was going to be the year of ARM, was kind of the line, just like this is the year of Linux on the desktop, right? Well, we're actually there now. We've got the hardware, we've got the servers, we've got the middleware, we've got the ISVs and the applications on top. So this probably is this is going to be the year of ARM, and we're seeing that happening. But we do have some work to do on the layered product support. So we've got the main things there, and going with what Jonny said earlier about the ACM announcement, Red Hat Advanced Cluster Manager does support ARM fully, and that's the great thing for us. So you've got something to manage your environment and your OpenShift instances in ARM. And we've also got the main things that we think are interesting. So pipelines and GitOps are there, and obviously you need some logins. So those pieces are done, but we haven't got everything yet. We're aware of that. We're beavering away to get the other pieces there, and you'll see that fill out as the roadmap goes on. So, okay, so that's my ARM pitch. As you can tell, I've drunk the Kool-Aid. I had the fortune to speak to John Masters when he used to work for Red Hat, and he definitely did a Jedi mind trick on me. So I'm all been on ARM, but there's a new moment coming now, and the 4.13 release was the new moment for OpenShift, and that's the idea of heterogeneous clusters or mixed architecture clusters. You'll see the things kind of being interchanged, and this was the right-hand side of the slide that we had on very early on. And, with Jeff and Andy and the rest of the team and a help of a few customers, we went away and we wanted to look at the main use cases. And these were the three main ones. Now, these are not the exclusive use cases at all, as I find that you, the customers, are much more clever than I am and come up with some wild and crazy use cases that we haven't thought of. But these are the three main ones that we see. So starting on the left-hand side, this is probably the most common one that we're seeing right now and that we're going to go after. And this is architecture migration. And that's the idea that you're on an architecture and you've decided that your future is running on a different architecture. Now, as you can see from my gray hairs, my experience in the IT industry is long, probably not very distinguished, but what I have found is the projects that always scare me the most are the ones that have the big bang approach, right? They're going to change everything overnight. It's all going to switch over to something brand new. And those are the ones that have much more risk, usually much more stress attached, and usually are delay after delay after delay. What is much better and much more successful in my mind is the small, let's snap a piece off, take baby step approaches to it all. And this is what we're enabling with this idea of a heterogeneous cluster. So you've got your cluster, your x86 cluster, you want to move over to ARM, say, so you can do that in a with little baby steps, just very easily add things in. And if you're on the cloud, that's incredibly easy right now. They've got ARM instances, so you want an ARM instance in your cluster. Jeff's going to show you how easy it is to add one in now with OpenShift. And that facilitates this gradual rollout. And it gives you some interesting opportunities there. You can bring those change the services that you want to change over first, see how they go. You can even do kind of benchmarking, check how they are. And this is very useful to some of our customers because even though it doesn't take too long to spin up an OpenShift cluster, it might take you a while to set up your OpenShift environment or your application environment the way you want it. There's a customer that we work with now that it typically takes them 2 weeks to kind of get their environment where they want it to be. So, have been able to just pull some ARM nodes into an existing environment is really powerful for them.
Hey, Duncan, are you guys working with the migration toolkit at all?
We aren't. No, that's one of the areas that we want to talk to. Right now, our focus has been, and Jeff will show this, but our focus has been on just making this thing, one of these things, multi-architecture compute, very, very easy to run and pull in. So we're kind of starting on that ecosystem, but definitely it's an interesting idea to try that out. Hopefully you won't need to. We can have actually, that's a good question. Maybe we'll put a pin in that around talking about migrating to ARM a little bit later on, because that is an interesting topic to get into. So the middle one, I love doing this really, really bad joke that no one laughs at, but this is for those of you like me with kids of a certain age, this is straight out of a Disney story called Beauty of the Beast. This is a tale as old as time. And I hope some of you now that have young kids of a certain age are singing that song in your head over and over. But legacy applications. So this has been going forever. This is where VMware came from with their virtualization. The idea here being you've got one or two things that, maybe you don't have the source code for them anymore. Maybe you don't have the person who developed them anymore. Maybe they just don't work on the environment that you want them to work on. Or maybe there are some big, very, very critical service that you need to keep going right now before you maybe break it up into containerized services and you just want to leave it running. So you have these legacy applications, classic applications some people talk about, and you want to keep them in the environment and have everything else running somewhere else. So that's the second main use case that we've seen called out. And then the third and final use case that I'm going to talk about today is around cost optimization. And this is kind of a switch in mindset here. The first two are very much aimed at your infrastructure admins, the people that control your environments. This last one is aimed squarely at, I guess, cloud providers, or if you've got an internal cloud that you use. And the idea here is that you want to, make the best use of your more expensive systems or more capable systems as pure compute nodes, and maybe you want your control plane to be of a more cost-effective system type. So the one that I actually use here is not ARM-based, but our IBM Z friends. You've got these mainframe systems. They're highly available, massive scalability, I/O off the charts, but you just really want your main applications to run on them. You don't necessarily want to use that estate to run your control plane, so you could stick an x86 or an ARM piece in there. And again, to go back to the call out I made earlier, if you've got providing a cloud service, and say you make your control plane based of ARM, well, if you're running on Azure, 10 to 20% savings there. That's kind of instant off your overheads there.
Yeah, it's significant.
We actually, Johnny, we did an internal kind of back of the napkin kind of calculation, and we think just because you're just doing the control plane, but we reckon about a 12% saving. So I've heard of some customers where their cloud bills are not or not in the millions or tens of millions, but in the hundreds of millions. So even just saving 1% off that's great money to take off your bottom line.
Wow, that's awesome.
Yeah, that's pretty. Like I say, I've drank the Kool-Aid, right? I'm sold.
Yeah. I mean, even in our internal group, right? We are eating cloud costs like crazy, and like it's like the conversations around like, well, we're spinning up these control plane nodes around x86. Yeah, it's just the standard way of deploying, right? So you have an M5 XL and AWS, and like it's not cheap over time. And so repositioning something or repurposing into an ARM, that's a significant cost savings, right? Like that's a legit thing. That's awesome.
Yeah. That's definitely, anyway, we can have another topic about that. Let's put a pin in that one as well.
All right, awesome.
So we've got two technologies to introduce you today. The first one is multi-architecture compute. And this kind of does what it says on the tin. Or maybe it doesn't say it on the tin, but the idea here is you start with your x86 cluster and you can add in ARM nodes into that cluster, and then you're good to go. But don't just take my node for it. There's a nice Freudian slip. Don't take my word for it. This is the point where Jeff is going to show us a fantastic demo of everything. So let me just scoot through. Jeff, over to you.
Hey, real quick though, can we answer a couple questions?
Oh yeah, absolutely. Yeah.
Yeah. So we got a couple questions from the crowd. The first one, let me see if I can find it, was from and I apologize for butchering anybody's name. Just putting that out there. But it looks like Jotaram. Where do you see OpenShift in the next 5 to 10 years? And each of you can take a stab at it, or
Yeah, actually I can. That's a nice segue into my very last slide, but let's do it now. So I think in 5 to 10 years, I think the idea of hybrid cloud that we've been talking about. So I guess I'll overshare on the show. So when I've been at Red Hat now. I think I'm coming up for 5 years. And when I was first interviewing for Red Hat, at the time the move was, cloud's the answer. What's the question? And everything was moving to cloud. And I was kind of asking at the time, where does OpenShift fit in that piece? And just like everything in IT, I think we find these things are pendulums. So it's like everything's cloud, everything's bare metal. The answer is actually going to be hybrid cloud in the middle, and that's where we play really well. And if you look at technologies like this, and technologies like ACM and ACS, and the things that we're doing with Quay, and the things that we're doing with ODF, they fit really, really well into this hybrid cloud idea. So I think that's where OpenShift's going to be in 5 to 10 years. We're going to be sitting there, everyone will be using it. And if you want to run your application in Azure, it will just nicely happen for you. And the network connections will be there to make sure it happens. The storage will be clever enough to make sure the data is in the right place to make sure you do it. If your application's well suited to running on ARM, then it'll run on ARM. And we're just seeing that. We'll just see that footprint grow. There's things like Red Hat Device Edge that's allowing you to run, kind of run this minimized OpenShift right at the edge on very small systems. So we'll be interfacing into that. So I think we'll just go to this, totally analogous, anonymous environment that you can just use anything anywhere. And then there's other technologies that we talked about at Summit, like CXL, that we'll integrate in, which the 5-second what is CXL is basically you can build your own system, right? You'll have compute, you'll have memory somewhere in racks, you'll have IO in somewhere racks, and you can kind of use CXL. It's gone into the chips now. Say, okay, I want to use this much memory, this much CPU. It's got fast interconnect. So that's a very long way of saying we'll end up in a very flexible world. And what will become important, I think, in those 5 to 10 years times is extracting away the complexity so that the applications kind of, you just throw them in and it just runs. I don't know if that answers the question or not, but that was my.
Oh yeah, no, really well, really well. I think like one thing that you keyed in on that, like, I completely agree with is like, if you look back to like virtualization, right? We went from physical servers to virtualized servers, then to containers, and then we've kind of it has totally been a pendulum, right? Like the technology, like it hasn't necessarily changed. It's just definitely gotten better, right? Like I think if you look back at Atomic, right? Atomic was just a little bit too early, right? But now we have CoreOS, and CoreOS struck at the perfect time, and it's the perfect product, right? So I think that like in my former life with the technology at the time as virtualization, we still wanted it all though, right? We wanted our VMs, but we wanted our bare metal, but we also wanted our containers. So I think like the hybrid cloud story, it's like it's always been the story and it's always been the plan, but now the technology is finally caught up with the idea. And like now we're actually going to see like the fruits of all that, the technology coming out and the pending and stuff like that. And yeah, I'm super excited. Like as a nerd, like this is like a great time to be involved, because we're virtual the way VMs are being handled now in OpenShift as Kubernetes resources, the way that we're enabling developers by making tools where they can just go and single click something and they can go and do their thing. We have multi-arch support on machines, so we're not limited to one type of machine anymore. It's incredible.
Yep, totally. So you mentioned 2 questions. Is there a second one? Or?
Yeah, there is. There's actually 2 more. So this one is from Azizu. I'm sorry. OpenShift remains an enigma, yet not enough content is created on YouTube, especially for how to integrate it with AWS. So I'll take this one on. I'm not exactly sure what you're talking about. Like if you're looking at like an installer provisioned infrastructure, or if you're talking about just like a UPI based installation. The way that all of the installers work is that they essentially use Terraform on the back end. They'll use your credentials and they will provision out the cloud resources. If you want to integrate, like if you're talking about above the infrastructure layer and you're talking about applications, there are ways that you can use tokens and stuff like that to there's an operator, I can't remember what it's called, but essentially it will manage your AWS credentials. And then that way you can kind of create applications, or you can use things within AWS, like some of the Amazon services like EFS or whatever. But if you have like a specific thing that you're looking for that's not there, just let me know and I'll try and answer that directly. And then the last question is from Europe, and I had a feeling when we published this the stream that she was going to be here, because she's actually sent Andrew and I a question about this before. And the question is, I would love to know if there's a difference between OpenShift on IBM mainframe, Power versus Z, and OpenShift on x86. Which one is the more preferred, and are there any slight differences, or are there any differences?
So there is a excellent German slang word that I like to throw into every presentation that I do, which is Jein, which is a slang for yes and no. So yes and no. So if you look at the core pieces of OpenShift, as far as you looking at it as was it Mira? Did you say?
Yes.
As far as Mira looking at it, core is core. It will look exactly the same. Andy and Jeff and the teams have done lots of work to make sure that we build it in the same way, we use the same CI/CD tools, we go through the same QE pieces. So that experience should be exactly the same. Where you start to see deviations, actually, let me go back. Actually, let me not, because it's a building slide. Where you see deviations is kind of on the layered products. Now, if you look at the IBM Z side and the IBM Power side, my teammates in that group will shout at me, but we're kind of done there. We've got everything that we need. The only major piece that's missing is something called Quay, and that should come pretty soon. So you'll have all the pieces that you need. And Miria, don't worry about taking notes here. Andy and Jeff helped me build a KCS, which actually goes and details everything like this, because we do get asked this question a lot. On the ARM side, we've still got quite a few pieces to build. So we don't have service mesh yet. We don't have serverless. We don't have a build of Quay that runs on ARM, though that might not be an issue. I think ACS is coming, ACM's done, ODF's coming as well. So we're kind of building that out. So you'll see when we bring a new architecture online, we'll concentrate on the core pieces first, and then we'll go and squirrel away and get everything else in. But the idea is what these platforms morph into is what we call first-class architectures. And what we mean by that is they will launch and be available the same day. So when OpenShift launches, all the architectures will be available, and we will strive very hard to get everything on there. And the deviations that you will see going forward are just the main new projects that come along. Just because of the I hesitate to say this, but I'll say it anyways. The DNA in the company and the engineering will tend to do things on x86 first. That's our biggest platform by far at the moment. So you'll see things there first. I'm going to talk about something called hosted control planes once Jeff's done his demo side. That's one of the things that we're concentrating on the x86 and cloud side first, and then the other architectures like ARM, like Power and Z will come a little bit later. As far as which one you would choose, the whole idea behind us doing this is that you choose the right one for your application and your services. So I was talking to a large financial institution, and they were explaining how when they bring a new service online, it's almost like they've got this intricate flow chart that they have to go through of a bunch of questions. Is if 1, go to 3, and that decides which cloud they run in, what architecture they run on, and everything like that. And what we're doing, and what Andy and Jeff are helping me do, is that we're making it an environment where what architecture you run on gets eliminated from that decision tree. It's not a forcing point anymore. You just look and say, okay, I've got a web service that's not doing particularly much. I just want to run it on a highly efficient server. So, okay, I can run that on ARM with OpenShift. I've got this high-end database application that hooks in that I need to get data into really, really quickly, and latency is very important. And I need it to be highly available. I might need that to run on my IBM Z platform. You can do that, right? So we'd like to be in a position where essentially my short answer to your question, and Jonny knows I never do short answers, would be anything you want. There's no recommendation. I think if I'm realistic, what you need to do now is kind of what we look at this link that I'll give to Jonny, which kind of says here's the differences, and you kind of look at what pieces that you need, and if everything fits, then you can run on whatever you want.
Nice. So Stephen Reeves said, "Hey, I just want to see a cluster of Z mainframes managed by a few Raspberry Pis."
I want to see you tweet about that and tag me on it. That'll be cool.
And then Dwayne Branch, longtime viewer here. So thanks for coming back in, Dwayne. With all the advances, what things will become obsolete, or will a cost savings make things, or will a cost savings make things obsolete? Like, essentially, will the tech make it obsolete, or will it ultimately be like the cost savings that drive it away?
So that's an interesting one. Given the experience that I've got, I don't think you can ever choose between the two, because there's different disruptions happen at different times. So there's always this drive around cost. I think that's always behind a lot of things. But then you get these disruptive technologies come around every now and again where it all goes out the window. So, who hasn't been talking about AI recently?
Right.
And look at the effect that that's had on the market, where you've had chips that were, very much aimed at the game industry, but quite expensive. Now everybody wants them, and that's the run towards that side. So that's the technology driving things for my mind. And then you've got the ARM side of things, where on the cloud space, I wasn't joking before. I didn't want to say it because I always misremember things, but I'm sure we were talking to a customer where they were saying their yearly cloud bill was $500 million, right? So if you can wipe just 1% off that, never mind the 10% saving that we're possibly talking about, then you're going to get driven by cost.
Yeah, it's incredible. Like I know, just coming from my customers, like it wasn't in the millions, but it's definitely in the hundreds of thousands, and that's a lot for organizations to eat, right? I mean, like, especially when you're a profit-based organization and you're trying to make money and you're just gouging out to these public clouds. Yeah, it's important, right? And so every little bit counts. I mean, that's why people use spot instances. That's why people use like the different things within the cloud providers to try and like cut some corners, right? Like it's coupon clipping, right? Like, I'm trying to save some money. So if we can give that back to them, I think that's incredible. So okay, Jeff, I know you want to do your demo. I know you're dying.
I'm dying.
So
yeah, man.
Whenever you're ready, let me know and I'll share your screen.
Okay, well, let me talk to this slide here real first. I'll give everyone a quick overview of what goes on here, and then I'll show you basically the result of what happens. So kind of starting from the top here, you can go ahead and create an OpenShift cluster with IPI on Amazon. And basically when you do that, what happens is you have a completely 100% x86 cluster. The payload and everything's is x86. And basically when I say payload, I mean the OpenShift payload that has the release version and then all the components of OpenShift, etcd, Prometheus, et cetera. All that stuff is all built x86 in that payload. And so to enable multi-arch, what you need to do is basically upgrade the cluster to the multi-payload. And all the multi-payload is, it's basically a manifest list of the x86 containers, ARM, IBM Z, and IBM Power, all in basically one release payload. So the payload itself is manifest listed, and all the components inside of it are manifest listed. But at the end of the day, it's the same code as you would get from the x86 cluster. There's no like engineering logic inside the release payload that makes it multi-arch, other than the fact that we've published everything under a fat manifest list. So essentially what that enables us to do is once we upgrade to that payload, I can deploy a node via machine set, or if you're on bare metal, it's basically a very manual thing where you deploy RCOS and then say, hey, here's the ignition config from the cluster, and it'll just join the cluster, and then the pods that spin up on those new nodes that are other architectures look to that manifest list and pull down the right architecture to run themselves on. So there isn't anything funky happening in like the OpenShift API that makes this work. It's just due to the fact that everything's manifest listed and the client knows what architecture to pull down.
That's awesome.
Yeah.
That is awesome.
But there's a caveat with that. So when you do that and you have and I'll kind of get into this a little bit later, but when you do that, you have a node of a second architecture. The scheduler really isn't architecture aware, so it really falls back onto the user to taint and tolerate that node accordingly, so other x86 workloads don't get scheduled to that thing. You almost treat it like a GPU machine at this point. So let me share my screen here, and I will kind of take you through a tour of a cluster I already have up and going.
All right, and I shared the link for the 4.13 multi-arch support, as well as if you're looking for a list of those items that are supported by like a specific architecture. Go ahead and check out this solution on access.redhat.com.
All right, cool. Thank you.
All right, awesome. Thank you. All right, you're good to go.
All right, appreciate it. So yeah, so this guy started its life as an x86 cluster in Amazon US East 1. And I'll kind of go down here to cluster settings. And you can see when I did the multi upgrade, and it's basically just an OC admin upgrade command -- multi-arch. You can see it in the docs there. And when I do run that command, it basically does a full cluster upgrade. Now, it's kind of confusing, like maybe the first time you go through this, because you're basically upgrading to your same version. You're just upgrading to a manifest listed container, but it has to happen. Otherwise, everything in the cluster will be single arch. So once you're at that point and you have the multi-payload, you literally can go over to machine sets. And I cheated a little bit here. I just took an existing machine set and changed the Amazon instance type and the AMI. And that's all you really need to do. I'll go ahead and do it here live on just another machine set, just so you can see what's going on. So the instance type, M6Gs, I think there's like M6G, M7G in Amazon, C6G. But anyway, the G ones are the ones that are ARM. And the AMI, you'll need the AMI for the region as well. And this is pretty well spelled out, I think, in the documentation that you put in there, Johnny. So if I just go to another machine set and just edit the YAML file, it's literally changing the AMI and the machine type or instance type to M6G. Save it. So here's an M6G extra large now, and then I can just scale it up, and it takes the same amount of time as it would an x86 machine or whatever. And that's essentially it.
Have you guys done this on the control plane machine sets?
Yes, but it's not supported. I think there's some other things in play there. There's certain components of OpenShift that I'm drawing a blank on that use the control plane architecture.
Okay.
For things. So if you started with x86 and went to ARM, I'm not sure what behavior you would get. I think image streams kind of come to mind.
Okay. It's definitely a great ask, Johnny, because it is one of the things. Jeff's tap dancing very well here. It's one of the things that we're looking at. If we think about the example that we talked about earlier about this cost-effective control plane, then helping our customers move to that space is something we're very interested in. And there's something that I always get mixed up on that we have that allows you to kind of change the control plane and migrate it to more powerful systems and everything. So we're looking at using that mechanism to see if we can jump architectures at the same time. So it's a really good ask. It's something we want to do. We want to make sure we've got all the basics in place first before we kind of play in that space. But yeah, it's a great idea. I'm glad you thought of it as well. That's
it's so like I think it was 4.12 when they GA'd the control plane machine set, and we talked about it for a little bit on one of the live streams. It's oh my God, amazing. I mean, just from an infrastructure person, right? Because I've done the like, oh, oops, I can't delete that machine, but I did. How do I recover this? And it's such a pain sometimes, especially if you're in like a cloud environment, because you're expecting the machine set, or you're used to compute nodes machine sets, and you're like, oh, it'll rebuild, and then you're like, this isn't happening. And so like it gets a little dicey, and then etcd recovery is not always it doesn't always work, and it's not a straightforward process. So this is exciting. I think that being able to have like I'm sorry, the nerd's coming out. Like I'm just getting super amped up just thinking about all the possibilities.
Yeah. So essentially this is it for the demo. I mean, it was pretty straightforward. I didn't want to make it overcomplicated here. It's literally making sure you have the right release payload and then adding in ARM nodes. One thing maybe I should point out here, on one of my ARM configurations or machine set configurations for ARM, you can, I'm sure most people know this, but if you're doing this for the first time in a cluster that's all x86, add a taint into your machine set on your ARM nodes just so things don't get scheduled there accidentally. Because the scheduler, like I was saying, is not architecture aware. It doesn't have a mechanism to basically pull a pull secret for your containers, inspect it, and then know what to do.
Gotcha. Now, there's no subscription difference, right? Like it's literally like if you have a Red Hat OpenShift subscription, it doesn't matter what platform. Okay,
so let me be super clear on that, because you said it doesn't matter which platform. So for ARM and x86, the subscription is exactly the same. So you just buy the same subscription. For IBM Z and IBM Power, they are separate subscriptions that you need to buy for them. So in the environment that we support today, that Jeff's just going to go into, where we're just basically saying multi-arc compute supports ARM as a day two thing, then you're good to go. You can mess around with this as much as you want and not have to worry about it. We do have plans to introduce Power and IBM Z into this later on. Then you're going to have to be a little bit more clever with your subscription management at that point.
Okay, no, that's cool. That's fair. So we got a couple questions that came in, and let's see. The first one is there a? Okay, actually, I'm going to read the wrong first one. Here's the first one. Is there an example of the decision tree available for public or even partners, as far as like the conversation you were having with Mira earlier about like when you would use IBM Z over?
We don't have one, Johnny, because our kind of thing is run anything anywhere. The decision tree that I was talking about was actually the customer's decision tree. So we were looking at the points in it. So it's not something we even got to see. It was kind of proprietary to them. They were just talking about certain points that we want to limit. So I guess that's a long-winded way of saying we don't have one because we hope you won't need one, because we're going to enable you to do anything anywhere.
Okay. Awesome. And then Stephen had asked, is there a use case or workflow for spinning up cheaper ARM nodes for test clusters that are more ephemeral than your main or prod clusters? Basically from like the ACM GitOps perspective, right? Like, is there, are y'all developing like any kind of like, I don't know, Helm chart? Well, I guess it wouldn't really be on you guys anyways. Like, do you know of anything going on like that? Like,
yeah, we haven't seen it. It's an interesting ask. I guess, again, to maybe overshare, because I love to do that because I love the sound of my own voice.
We love it too.
Well, I don't know about that. So we're kind of looking at this project's almost in phases. So the first phase was just to get it all working, and that's kind of where we're at now. It was GA in 4.13. So you can go and do that with some limitations that Jeff's going to go into in a moment. The phase 2 for us now is looking at how can we make the experience better. So you can kind of go anywhere with that, Johnny, and this would be interesting where, if people listening kind of had a go at just putting some comments in about what they think would be useful to hit. So things that we're thinking about, and sorry, Jeff, I'm going to steal a little bit of your thunder, is So we don't. This technology is, I often describe it as a very, very sharp pair of scissors. So it's extremely good for cutting things, but you need to be careful and just walk with it and carry it the right way. So we don't do anything around scheduling, for example. So we don't put taints and tolerations in there. That's an exercise for the end user at the moment. We want to see how we can improve those types of experiences, and kind of the sky's the limit here. So you could look at how can we do clever things around scheduling to make that easier. But what about cost models, right? To the question that came in is, can we do something clever working with ACM where you know what cost models are, and maybe you have the control plane migration tool or whatever we call it as well, so that it helps you through. So when those are kind of things that are quite a way out, that we're now in the mode of, okay, what can we do next? So I think, again, the short answer to that question is we don't have anything that's looking at ephemeral things and doing it right now, but we're looking to do that. And this kind of lines into the other comment around there's not a lot of content. I'm definitely in that mode now where we're trying to create a lot of content around this. So you'll see more coming out.
Okay, awesome. And then, so Dwayne asked another question. He says, as Red Hat is pushing serverless, how would this fit? Is serverless a supported operator on top of?
So we don't have serverless yet on top of ARM. So it's not there yet. But my answer to that is once we have it, I think it should be invisible. So the whole idea of serverless, in my poor understanding, is you just give some functions to run and they run magically and everything happens. So I think the benefit would be for the cloud provider in that, those services could run on, okay, let's say it, more cost optimized ARM boxes if they needed to, invisibly to the end person using it.
Nice. Yeah, I believe I like that analogy, right? Like as soon as you go, the underlying CPU shouldn't matter, right? Like once it's all configured and your infrastructure set up, like it should just run the way it runs, and you shouldn't have to adjust. And I was kind of thinking about this as I was reading Dwayne's question. Like, I don't think service mesh was on there yet, but like when service mesh does happen, and this is probably not the right place to ask this question, but I guess ultimately infrastructure nodes, right? So if I wanted to have like an ARM control plane, would I be able to have like an x86 or maybe even like a split ARM and x86 infrastructure node type work, so that way I could run things like the router or what, you know what I mean? Like just some of those other things.
It's probably doable. The only thing we're putting a red line through right now is mixing architectures on the control plane. So we don't want to go down that rabbit hole. That's kind of Pandora's box territory. So we don't want to do that. Andy was nodding though, so I'm going to believe that he thinks it's possible.
I mean, it's possible. I probably wouldn't recommend mixing architecture on control plane though. Just because you'll get different performance out of each of the hosts, and it could like skew the way things get handled. And I think you're opening yourself up to some pretty interesting issues that you probably just want to avoid by keeping it the same.
Well, especially production, right?
Yeah. We should be good for the infrastructure nodes, though, Andy. Do you think?
I'm going to say yes, but I think it would need quite a bit of test. I mean, I think the thing is, the reality of it is, will it work? Being the first question, yes, it'll work fine. Like we've done some like mess around testing with a control plane where we had different architectures, and so I think that infrastructure would work just as well. But whether it's a good idea and it needs to be tested and just make sure, especially in production. I guess in not production, go for it, have fun, try it out.
Yeah.
But yeah.
It goes back to the old, yeah, you can do it that way. But why? Why would you? Or why should you? Just because you can doesn't mean you should.
I think like a kind of cool vision would be to have all your infrastructure and control plane running on ARM, because why would you want to spend more money on your like control plane and infra hosts if you don't have to care where they're running? And I think service mesh and serverless having those applications running on top of ARM would make a lot of sense once we have support for that. But there are always instances where you would want to run things on x86 or other architectures like IBM PNZ. So yeah, I think like Duncan said, the key thing is like being able to choose. But I think when it comes to control plane, you want to pick one and stick with it rather than kind of have a mixture going on there.
Okay, gotcha. No, I figured I would ask. Okay, so Jeff, do you want to finish up? I'm sorry, we kind of
No,
took
man,
off.
I'm good. Yeah, I'm going to kind of lump in the first 4 bullets here just to save some time. But basically, we support the multi-arch payload from install time as long as all the architectures on the control plane and worker nodes are the same. Upgrades work the same as they do for single arch. You have basically an upgrade, a multi-upgrade Cincinnati server behind the scenes that does everything in parallel with x86. You're not going to get like a multi-arch cluster release behind the single arch clusters. They're all in parallel. Kind of talking a little bit about the image stream stuff. Basically, the old way, the image streams and even build configs too, those are single arch things. I think in Andy, was it 412 or 413? I'm drawing a blank here, but we upgraded image streams to actually pull through a manifest list image into the registry. And I believe the registry is also supports manifest listing now as well. So
that's new. I think that was in 413 because it went from like the image content source policy to like something else, right? I can't remember what it's called, but yeah, it definitely, the way that stuff is configured now, it's a little bit different.
Yeah. We can go ahead to the next slide.
It was kind of a key thing adding the manifest list support to the image registry. For us, that was a pretty big deal. Because before it made it really difficult to store images inside of OpenShift without having them like totally separate images, like image1.arm and image1.x86. So now you can just
doubling up on everything, right?
Yeah, just have a lot more, be able to be a lot more smart about how you do things there.
Jeff's underselling it. The thing I liked about it is OC debug didn't work. So when you had an image registry that was a single architecture and you ran OC debug on an ARM node, it just didn't want to know. So the team did a lot of work to make sure those things kind of. And again, it's about, sometimes it's where, what is it? I can't remember, Convoy or something like that, wasn't it? Where they talked about Rubber Duck and he was like very smooth on the surface, but underneath we're paddling like mad. So
yeah,
the team's been doing a lot of that. So let's give Jeff the next slide. Here we go.
Yeah, so just kind of review some of the limitations. We talked about a couple of these here, but like I was saying, the Kubernetes scheduler is not multi-arch aware. So it's really up to the user to set node affinity, taints, tolerations, labels, or however you decide to do it. Treat it like GPU nodes or whatever fits your use case there. Day zero implementation is not something we support. So that really means that at install time, you need to pick the architecture of your control plane and your workers. We're not supporting x86 and ARM at install time. Disconnected installs, the multi-payload, because it's manifest listed, some of our tooling doesn't support copying all those containers down as a manifest list and moving it to another registry, at least not yet. That work's in progress, and hopefully soon we'll have it. Auto scaling, basically, it kind of goes back to the same issue with the scheduler. The autoscaler really doesn't know what architecture your things are running. So again, you have to basically label and taint and tolerate for it to work properly. It's same with autoscaling from 0 to, like there's issues there. We know about them and we're working on them, but basically it's not automatic. There's user intervention required there. And the last thing I'll talk about here is the OpenShift build classic. So basically we have image streams and they're in the registry, but you don't really have a build config that would know what to do with those things. So you can't just say, hey, build this. I can't say build, say this sample on both architectures. You would end up with 2 streams basically from the same source image. And then you would have to figure out how to stitch the output of those things back together for it to work. And that's essentially it here.
Okay.
Excellent.
So if it's all right, Jonny, if you've got no more questions, there's one more thing I wanted to touch on.
Yeah, we're good to go.
Excellent. So the stuff we've talked about so far, OpenShift running on ARM, the multi-arch compute, that's owned by the team that Jeff, Andy, and I live in. But there is another technology that we have to talk about. And I don't know if you've had a session on this already, Jonny, but maybe everybody hasn't seen it. This is worth a whole hour and a half in itself. And we've got a tech preview out of it, and it's something called hosted control planes. And the reason that I'm talking about it is it fits very well into the third use case that I was talking about. This is the cost efficient control plane. For those of you that haven't heard about hosted control planes yet, and there is a ton of information out there if you want to go and search for it. Adele, who's the PM, has done a great job of talking about what it does. But I will completely undervalue what the engineering team have done. And the way I describe that is what the team have done is containerized the control plane. And that has some amazing, deliberately designed in benefits. And I'm going to randomly choose the kind of ones that I've got on the slide here. But the first one is you can lower your CapEx and OpEx costs. And the way that you do that is because the control plane essentially now runs in a pod, you can have multiple control planes side by side. So if you're looking, let's mix the architectures in. If you're looking at a IBM Z system, in your standard config, you're talking about an LPAR for each of the control plane nodes, and then an LPAR for each compute node that you have. It soon gobbles up the capacity of your box. But those systems have a lot of redundancy built in, so you can actually take hosted control planes as an idea when it comes out on IBM's Z systems of course, and have multiple control planes side by side, i.e. multiple clusters there. So you can do, again, another tale as old as time, consolidation down and save yourself money. There's also in hosted control planes, the way it's designed, there's almost this separation of church and state between the control plane and the compute nodes themselves. And that gives you some interesting models around network and trust segmentation. So for example, a developer role that's living on the compute nodes has no view into the control plane at all now because of the way we connect things up. So you kind of segment that off. There's also a benefit because you're consolidating these things down, and it's all managed through multi-cluster engine, MCE, which is the baby brother of ACM.
Mm-hmm.
Then you've got this central management of the control plane. So that makes it easy operation and maintenance. And then my favorite thing of the immediate that's available now is, and I'm going to use the word just in a really offensive way, but the control plane becomes just a pod. And if you want a new control plane to boot up, that's going to happen really quickly compared to installing a thing from scratch. And in the cloud world, I don't know if you're all like me, but when I'm in the cloud and I press a button to get a new thing, I want that new thing straight away. And I want it as quickly as possible. And hosted control planes is going to do that really quickly for you. So this is like a really big change. If you've got an internal cloud offering or you're doing some cloud provider things, this is going to mean a major change, a great beneficial change for you. But why am I talking about it? Well, there's a couple of future things coming along that make it really interesting. The first one that kind of lends itself to the question about 5 or 10 years, where's OpenShift going to be? And I mentioned hybrid. Well, there's the opportunity here that you can have your control, your compute nodes, your worker nodes, actually on different clouds. So there's an idea that you could have some in AWS and some in Azure if you wanted to do that. And that could be based on the pricing model of what you're doing. It could be based on maybe some ideas around HA or something like that. And the reason why I'm finishing off the presentation today by talking about it is there is also this opportunity to have a control plane of one architecture, say x86, and the compute nodes of a different architecture, say ARM. So if we flip that around, that's right in the use case that I talked about. So you could have an ARM control plane, making use of the cost-efficient side of it, and then have your x86 out there. So it's a great technology. I see Jonny, as always, is miles ahead and has posted a link to the discussion, a full discussion about it. But definitely have a look at it. If you're really, really in for a fun time, you can mix hosted control planes and multi-arc compute in the same environment if you really want to. But then we would have a long discussion about turtles all the way down, I think.
Right, and I think that goes back to Stephen's question earlier too, right? About like how a use case for managing like dev environments that may not be, like production workloads, right? Like just, let me spin something up quickly, low cost, do my thing, and then fly away, right?
Yep.
This is an awesome way of doing that, right? Like, and then having the multi-arch support where it's like, okay, go spin up a single node ARM or maybe a 2 or 3 node ARM cluster, do your thing, get commit, push, fire away, you're dead, kill the cluster, and like you've only spent a fraction of what you would have spent yesterday, right? If you weren't using this. Sorry, I didn't mean to cut you off.
I think you make a great point. For me, it's and we've heard this mentioned for a while. The things about pets versus cattle.
Mm-hmm.
And we seem to be pushing that boundary. I mean, I remember the old 3.x OpenShift days, right? You installed that cluster and you never touched that damn thing again, right? Because
Glory
it was
days.
so hard,
Yeah.
so hard to get going. And what we saw very few very large clusters typically, and then you had things move stuff along. So with OpenShift 4, we re-architected, so we made the install and upgrade experience easier, and we saw that reflected in telemetry. So we saw more and more customer clusters kind of appearing at customers because they were much easier to create and they were much easier to maintain. And hosted control planes is going to take that to extreme. You need a cluster in your environment, you just spin up a new one and on away you go. Which very nicely, thank you, Jonny, brings me on to my last slide, which is, hybrid cloud is multi-cluster and multi-architecture, this environment that we talked about where you're going to have that hub and you want to run in a public cloud, a private cloud, bare metal, secure cloud. You want to run on ARM, you want to run on x86, you want tools around it to manage it, to secure it, to have your data, to have your images. It's all going to be there. You're all going to be doing it.
Oh man, I love it. I love it. It's exciting.
I hope so. Now go out there, everyone, and install some OpenShift clusters on our ARM, so we can see our telemetry numbers go up, and we can
Right?
feel self-satisfied with
They
ourselves.
all love it. It's amazing. Yeah, I'm super excited about this, right? Because in my experience, it's been the combination of like a private cloud, either it be OpenStack or some region in like the GovCloud, something like that, or they've got some bare metal somewhere, or now like with the edge conversation poking up, like we're seeing a lot of this. And I had a customer that was really interested in like the multi-cloud story, and like they then like Raspberry Pi, the single board computer, all this stuff was like it became the Chat GPT of its time. Like it was just like everybody was talking about the single board computer, and so like that's where that conversation started going. So like seeing that all these things are finally coming out and we can have multi-cloud, like legitimate multi-cloud, bare metal, and then things like Scupper that like eventually we'll be able to actually talk to all of these things, or our applications will be able to talk to each other in all these different places. Like there's a big story that's being told right now. It's not done yet. I am amped up about it.
Yep. It does feel to me like it's not only the year of ARM, right? It's going to be the decade of hybrid cloud as well, even though it's already been the decade of ARM. So.
Yeah,
Excellent.
but just the simplicity of it, right? I mean, like I think that there's a lot lost in that translation when somebody goes and they're like, oh, I just do a thing. I just updated a machine set with an AMI ID and a node type, and it did it. All that complexity that went into building that simple click, right, or that simple change, that gets lost, and all the engineering effort that's gone in to make all this stuff easy. It's bravo. It's really amazing.
So that is it, Jonny. I don't know if there's any more questions. I didn't see any squeeze past, but you've been good at eagle-eyed at pointing them out. But I don't want to keep people too long either. I know it's very tiring looking at my face for too long. My wife tells me that regularly. So
yeah, we don't have any more questions. I do want to, Jeff or Andy, if you guys want a chance to close out with some comments, then what I'll do is I want to publicize some things that we've got going on the other side of this. But go ahead if you want to make some closing statements. Oh, and before you start, we actually got a question. So can you do multi-environment hybrid cloud within the same cluster, bare metal VMs either on private or on public cloud with Mulit-Arch?
not yet. So the slide we're looking at now, that's kind of a features thing. So this is where we're building out to right now. So it's not. I think hosted control planes, you might be able to play with it to do it, but as Andy kind of hinted at before, we're, as well as solving some problems, we're making some problems at the same time. So as you become very flexible about where you go, we need to make sure that OpenShift still has all the enterprise qualities that it needs. So we need to test those environments. And, if we had more time, one of the topics we could get into was a discussion we had internally. So right now, we've got 4 architectures that we can run OpenShift on. And people quite rightly started asking the question, do we have to test everything on every architecture? And, there's interesting discussions have there. And that's kind of lends itself into what I'm showing on this final slide as well, in that, you know, once we start opening up things to be that configurable, we need to make sure it all works. So this is a vision of kind of where we're heading to at some point. And we've got a lot of pieces now, you know, ACM, ACS are multi-cluster aware, so that kind of fits really well into this. But the whole spanning the different kind of cloud environments, that's still something that, you know, you could kind of do it with stretch clusters and things, but it's something we're still kind of filling out.
Yeah, definitely agree. All right, so Mira, hopefully that answered your question. But yeah, so Andy, I don't know if you want to close out, if you had anything you wanted to add or anything like that, or if you're good to go.
Yeah, I think I'd encourage everyone to just give it a go if you have an opportunity, especially on AWS. It is pretty straightforward. There's no one. I think one of the coolest things about it is there is no real magic there. You know, we haven't tried to make things like overly complicated. It's all just as straightforward as we can. And I know Duncan mentioned it, but what that does result in is you get kind of a situation where you've got this like really powerful tool, but you can do bad things with it. So just, you know, be careful, but try it out. You know, try some workloads, try building stuff on ARM from a multi-op compute cluster, and if there's any feedback you have after trying it, definitely let us know. We've spoken to a couple customers that have started using it and have had some really good feedback. But we're always looking to make it simpler and to make it easier for people to use and kind of automate out those bits that seem a little bit manual and tricky. But yeah, hopefully people can get some really good use out of it.
Yeah, that's awesome. Jeff, hey man, great job on the demo.
Thanks, Matty.
It went really well.
Appreciate it. Yeah, I just kind of extend what Andy said and what Duncan's been saying. I think just having more use cases and more people doing this will help us maybe steer the ship in the right direction. I think right now we're at a very good starting point, right? But there are some manual things that I don't think it's clear on how we want to address yet. Scheduling being one of them, right? And how to do like multi-arch builds in a cluster, things like that. So please give it a try, give us some feedback. Just any more details on the use cases would be great. Also want to mention too that a few of us are trying to contribute to OKD. And so hopefully multi-arch and OKD will be a thing someday.
Very nice.
So if you have a closet full of Raspberry Pis and System Zs, jump on it.
All right, Duncan, do you want to add anything?
No, I just wanted to thank everyone for their time and the questions and the chat. It's been really good. Just to emphasize what the others have said. Reach out, let us know how you're getting on, try it out. Tell us all the cool things that we haven't thought about that need doing. That would be great.
Yeah, definitely. And to Jeff, to your point, like it's baby steps, right? Like we got this out there, we've got a capability now. Now we've got to figure out like, okay, how do I tune it? Right? How do I help it grow? Right? And then so it's just getting these little kinks worked out, and then like with the build configs and stuff like that. So it'll be nice.
Yep, exactly. Yeah. Let us know.
Yeah, for sure. So with that, if you want to contact Andrew, Sullivan, or myself, you can either hit us up on email. So I'm Jonny@redhat.com, or Andrew is andrew.sullivan@redhat.com, and I'm going to throw stuff up here. Or you can hit us up on the OpenShift users Kubernetes Slack space, and here's the link. And also, there is an OpenShift Commons Slack. So if you're interested in OpenShift and you want to find out more information, and you just want to ask a question in a public forum where there's a lot of people looking at it, then the OpenShift Commons Slack channel is here. So it's openshiftcommons.slack.com. So you go ahead and register. I'm on that. My team is on that. I'm not sure if Sully is, but between OpenShift users and OpenShift Commons, we'll be able to help get your stuff answered. So, guys, thank you so much for coming on. You know, like I'm really glad that you were able to make the time and come out here. This has been great. Lots of information. I'd love the feedback from the audience. You know, like it's good when we get a bunch of conversation because you know that the topic is important to people, right? Like, so, it's something I think that we're all excited about as nerds and, you know, wanting to get out there and do all this crazy stuff on all these cool things. So I'm glad to see that we're moving along with the industry and we're not like the government and we're just kind of sticking around and using 5-year-old products. So, but yeah, with that, Andrew Sullivan, I miss you. Come back. I hope everything's going on, or I hope everything's good. And next week we have DevOps with OpenShift. Then we have the break for Independence Day here in the States. And then I think on the 12th, I'm not exactly, we're waiting to confirm, but we've got a couple things lined up. Just like what we were talking about earlier. So we're trying to get Service Mesh, we're trying to get Scupper. We're working with a couple of partners as well as the Red Hat Open Data Science team. So we've got a lot of things coming up. So it's going to be a busy couple months. So I'll start putting things out as we know for sure. But guys, thank you again. Really do appreciate it. And unless you want to say bye or whatever, then we'll go ahead and call it.
Absolutely. And thanks for being a really good host, Jonny. It made us all feel really comfortable.
All right,
Thank you, Jonny.
Yeah, you guys are awesome. Next time, wear a hat, Jeff.
Hey, I will. Hold on. Close out with the hat on.
Yes, we win. All right, guys.
See you.